Hello, I'm James Flaten with NASA's Minnesota Space Grant, and I'd like to give you a quick overview of ballooning, lighter than air ballooning, especially for educators and students. I'm going to make a second video which focuses on weather ballooning, but let's do an overview of essentially all types of ballooning first. So I'm not going to take the time to read this abstract, but basically ballooning has been around for a long time. People started flying in balloons in the 1700s, in fact. And when you think of ballooning, well, many would come to mind. And I'm going to show you the ones that come to mind and perhaps some of the ones that you are less familiar with. So when I say balloon, the first thing that comes to my mind actually is a party balloon. It could be a foil balloon, sometimes called a mylar balloon. It might be a rubber balloon. This is actually pretty clever, where people have taken a bunch of rubber balloons and made an arch with them. Throughout this presentation, there's going to be lots of links. I'm not going to follow all the links, but if you want to, you could take a look at the slides and you could follow the links yourself and learn a bit more. On the other hand, here are much bigger balloons, balloons that are intended to carry people. The one on the left is a much older photograph with the balloon inside of a net and a basket underneath it. And the right side is a hot air balloon, except this particular one is tethered. In other words, it's not a free-flying balloon, but you can free-fly hot air balloons as well. So these are other things that come to mind when people talk about doing ballooning or lighter than air ballooning. Here's a few issues and some vocabulary, okay? So a balloon is something that can hold gas, and presumably you could make it from a variety of materials. The original balloons were mostly made out of fabric or perhaps paper. Nowadays, balloons are made out of plastic or rubber. Rubber in particular is stretchy. And so if you have a stretchy balloon, then you have to make sure it's sealed. On the other hand, if you have a fabric balloon or a paper balloon, often it's not sealed, but presumably it encloses the gas, which is lighter than air by definition. And so the gas wants to go up and the opening would be on the bottom. We're talking about lighter than air ballooning. And so Archimedes' principle says that you will get as much lift as the weight of the air that you displace. And as long as the weight of your object is less than the air that you displace, on average, you will be lighter than air and you can actually float in the air, perhaps to some limiting altitude. You need to think about lift gas. The three most common gases used for lighter than air ballooning are, well, hot air. It has issues of, it's hot, so don't burn yourself, but it's free, that's good. Helium, which is the most typical ballooning that I'm familiar with at least. But it can be pricey, it can be hard to get. And hydrogen. Hydrogen is actually slightly better than helium as far as a lifting gas. It's much cheaper and it's a little bit more efficient, but it has flammability issues if it gets mixed with oxygen, in particular if it gets mixed with air, which has oxygen in it. So you need to be very careful, of course, with hydrogen. And then the amount of lift you get depends on, well, the lift gas you're using and how large of a volume you have filled. There's an effect of pressure, because atmospheric pressure goes down, and temperature varies with altitude, of course. And then whether it's at night or in the daytime, so solar heating can make a difference. And if you want to be lighter than air, you need to make sure that the lift you have exceeds or perhaps equals the weight. So you have options with balloons. You can have tethered balloons, which are essentially tied to the ground. You could have free balloons, which are floating completely freely, or you could end often going up. Or you can have neutrally buoyant balloons, which essentially don't come down, they don't go up, and that was what you would want for like a powered system, like a blimp of some sort or a Zeppelin dirigible. When you're talking about free ballooning, in other words, balloons that drift with the wind and are not tethered, okay, presumably the balloon will go up and then it may burst. So you might reach a natural burst. And if that's the case, then the things that you're carrying, typically we call those payloads, would come back down again once the balloon is burst, presumably by parachute. If you drop ballast, you can not increase your lift, but you can increase the relative amount of lift you have compared to your weight by decreasing your weight. On the other hand, if you want to have less lift, you could cut away a balloon or two if you had multiple balloons. You could vent some of the lift gas out of the balloon that you have. This could slow the ascent or possibly even bring you to a floating state or even a slow descending state. And then if that's the case, then the balloon won't pop. And so you need to have a terminate mechanism. So terminate usually means intentionally burst the balloon with some sort of a popping mechanism, or else cut yourself away from the balloon, let the balloon fly away, unpopped, but then you will come down by parachute. So these are issues you need to think about with respect to free ballooning. And then as far as payloads, well, you can carry people, you can carry stuff, cargo. In the case of educational activities, you might want to carry smaller things like microcontrollers and sensors to explore your environment, or perhaps cameras to do photography. It turns out that if you have a tethered situation, you can lift these things just to a limited altitude. This has been done way back in the Civil War. There were actually tethered balloons that were used as observation points by the military, for instance. And then you can study the weather, of course, and you can study the winds by noticing where your balloon goes, because it will go with the wind. And you can get into environments that have some similarities, many similarities, in fact, to outer space. We call this near space, the stratosphere. And so you can test things perhaps before they go into outer space, just to make sure they will, in fact, operate well in these kinds of environments. Okay, so here we go, very quickly. Let's just see some pictures of different types of balloons. Well, here are sky lanterns, okay? I don't actually recommend this particular activity, although it's kind of fun and it looks cool. Basically, you make something typically out of paper. You put a fire inside of it, careful not to start the paper on fire, and you let it go. What it's supposed to do is go up, and eventually the fire will be extinguished, and then it will come down. Unfortunately, occasionally these things do catch on fire, and sometimes they come down still on fire, and there have been cases where they have started fires, so I don't recommend this, but this is something you may be familiar with. On the other hand, when you think about people being carried by balloons, France comes to mind. 1783 apparently was a good year in France. The Montgolfier brothers flew in November of 1783, and somebody else in France who heard of them, but was working on their own balloon using hydrogen. They didn't even occur to them that the other guys were using hot air. So the Montgolfier brothers had a flight in November with hot air, and literally 2 weeks later, okay, Jacques Charles did a flight with hydrogen, which was a much smaller balloon and went much higher because it was a better lifting gas, except for the flammability issues. So kind of coincidental that both of these things got off the ground, so to speak, just within a few days of each other back in 1783. Here's a picture from the Civil War showing a balloon being prepared so as to be tethered and used as an observation post. And here's a very interesting historical incident, and that is Zeppelin, the guy who became famous for inventing the Zeppelins in Germany. His first balloon flight was actually in St. Paul, Minnesota, which is very near where I'm living. I'm in Minneapolis. Okay. And so he was here in Minnesota. He was looking around Minnesota doing various things, and he went up on a tethered balloon. And apparently he was so taken with it, he went back to Germany and invented the dirigible, the rigid airship. So the center photograph here is his first airship. The one on the right is actually his most successful airship, which was called the Graf Zeppelin. You may have heard of the Hindenburg. That was another one that had issues, shall we say. It's just hard to imagine how big these vehicles were. And these vehicles were, flying in the very early 1900s. The picture in the middle was taken in 1900, and the Graf Zeppelin was flying in the 1920s and 30s. This is worth stopping and watching. Okay, so here is one of the American airships. This is the Akron. And just take a look at how huge this vehicle is compared to the people around it.
This is Dan Grossman from airships.net. On February 22nd, 1932, following congressional criticism of the safety and usefulness of the USS Akron, the Navy invited a group of congressmen to Lakehurst, New Jersey to show off the abilities of their new airship. Unfortunately, this is what the congressmen saw instead.
So it's swinging around in the wind. It's pivoting. It's moored, but they don't have a lot of control over it, and not a good day. That's water ballast being released. They released it a little bit too late, I say. And now when people get close to it, look at how huge this vehicle is when people are standing next to that tail fin. In fact, there are people inside the fin. That's one of their control cars. So just a massive vehicle, basically the biggest things that have ever flown. Okay, continuing with my slides here, Zeppelins or these types of airships, they have evolved some, but they fly today, okay? And so you may actually see them flying over. They're not as big as the old ones, but there are some new ones that are coming along that are being developed for cargo. And so they're not fast, but they can carry a lot, and they can carry a lot for a long distance. And this may well be in the future. Right now, it's under redevelopment, shall we say. Hot air ballooning. Okay, so turns out that Donald Picard, who passed away recently, I knew him, was the son of Jean and Jeanette Picard, who were big into ballooning back in the 1930s, and he died recently in his 90s. But he is essentially known for bringing hot air ballooning back, shall we say. And so this is something that I've never done myself, but I would like to. And in this case, you have an open envelope, which is made of fabric, and a big burner to keep the air inside of the envelope hot enough. And so you can burn and make the thing go up, and then you can turn off your burner and it will settle back down again. And so when you have a good pilot, you can find a good place to land when the time is right. Turns out that now people are developing the same sort of thing, except they're planning to take people all the way to the stratosphere. So the enclosures, of course, will have to be significant because that's a fatal environment, but the view is spectacular. So let's talk a little bit about stratospheric ballooning, not necessarily carrying people. Early stratospheric ballooning included Jean and Jeanette Picard. These were University of Minnesota people. He was a professor, and she was the first woman ballooning pilot in this country. And the picture on the right shows them actually inflating a balloon on our campus, literally. And they would fly in their balloons sometimes, and they would fly things on balloons without people sometimes. And the Picards. In fact, the Picard from the Star Trek is named after them. Here is what some of the stratospheric balloons that are made of plastic look like. So there are zero pressure balloons, which means they're not closed at the bottom. And notice the one on the left-hand side is literally as big as an aircraft carrier when it's launched. And eventually at altitude, it is essentially fully inflated. So you only inflate it enough to get it off the ground. And then as it goes up and gets in lower pressure regions, it gets more and more fully inflated, in which case it's not only as long as an aircraft carrier, but it's about the size of an aircraft carrier at altitude. On the other hand, you can also have, these look quite similar when you first launch them, but super pressure balloons. And they look more spherical when they're at altitude. And the reason is they're fully sealed. And so they fill out spherical volume instead of kind of a teardrop shape. We mostly do stratospheric ballooning. In other words, ballooning that reaches the stratosphere, but using rubber latex balloons, often called weather balloons because they're used by the Weather Service. So here's some pictures of a very small one, relatively speaking. This is to fly a GRAW radio sonde. And so this particular device transmits information about the weather it encounters. It's typically not recovered, and you need a ground station to pick up the transmissions. And it only weighs a very small amount of weight, and hence it can be lifted by a pretty small balloon. This is what I have a tendency personally to do more, and this is what I will call big weather ballooning. So weather ballooning is much smaller than those monstrous balloons I showed you, but there are FAA regulations, and you can fly, for instance, up to 12 pounds without very much regulation. And so the balloon on the left-hand side is being prepared for a flight that is 12 pounds. So that's about as big as my balloons ever look on the ground when I first released them. And then the picture on the right-hand side is from a flight and shows the fact that the sky is black and you can essentially feel like and look like you're in outer space. That's a clip from a video, and if you go to the link below there, you can actually watch the video if you'd like. So now very quickly, here's some comments for educators, right? What might you do with ballooning in an educational context? This is not an exhaustive list, but just some ideas. You can certainly study the history of ballooning. And so there's many books out there, especially books on airships. Here are a couple that I've enjoyed. There are movies. Here are a couple movies. Blast on the left-hand side is a documentary about a balloon flight. The Aeronauts is a fictional movie, but it's about real things that happen to real people. They just kind of made it slightly more movie-esque when they put it together. Here's something that I've done. I've used a weather balloon. So there it is, way up at the top there. And I've used it to lift things. In this case, I was lifting a glider and dropping the glider and letting the glider come down. And so this was a way for me to get the glider far off the ground, relatively speaking, when I didn't have access to like a big building or something like that. Found this on the internet. Basically, you can actually do hot air ballooning with balloons that are solar heated instead of having a burner. And so typically these balloons would be black and they would not carry very much weight. But these people reported that they had a balloon that traveled 400 miles. And it reached a top speed of almost 100 miles an hour while it was doing it. And it went up to about 50,000 feet, or just above 50,000 feet. So that's actually pretty impressive. Of course, they're really tiny balloons. Okay, so these are blimps. Air swimmers are kind of cute. They have a flapping tail to propel themselves around. The one on the right-hand side has little tiny propellers, and you essentially control it with your phone. So I've bought both of those toys and played with them some. And I've also, this is some pictures from a freshman seminar I taught where I had freshmen building lighter than air vehicles of their own design, frankly, and putting propellers on them and trying to control them. And it was fun and it was hard, and we learned a lot. Bill Brown does some really amazing things with small foil balloons, or I guess you could fly these tiny, tiny transmitters, solar powered transmitters that only have 12 grams of mass. And in fact, he can get these things to go all the way around the world sometimes. If you can park them just above the weather, these things go to maybe 30 to 40,000 feet. And if you can get it so that they stop there, don't burst the balloon, and don't come back down again, they can actually circumnavigate the world. I think his record is, let's see, 6 times around the world. So here's some tracking information from one flight of one of his little tiny units. I regularly teach freshmen to do big weather ballooning. So in this case, the freshmen put together payloads. We launch the payloads on these larger weather balloons, and then we have to get them back so that we can get the data off of them. And so here's some pictures from one such event. We launched 2 balloons. One of them landed in a tree. We got some nice pictures. We got lots of data. And it was an interesting activity for students who are not yet committed to any specific major, but they were learning about engineering. They were learning about aerospace. I know that North Dakota Space Grant actually does something similar, except they allow people to bring payloads to them from around the state, and they have what they call their annual competition. So build a stratospheric balloon payload, possibly with a specific theme, and then they will fly it. And that looks like something that I would like to do. In fact, I'm trying to do that right now. Here's something I saw over the summer in Montana at a workshop I was at, where students in Montana had built their own zero pressure balloon, and here they are laying it out, inflating it and releasing it. The nice thing about a zero pressure balloon is that when it inflates enough for the lift gas to reach the inlet, shall we say, it will naturally spill out. So these things will automatically float. You might have to work to get them to come back down again, but it's not hard to get them to stop going up because they geometrically have a limited height, a pressure ceiling, basically. Here's another thing that you can get involved in, and that is building payloads and taking them to fly on one of the massive balloons. So this is the HASP program, HASP, High Altitude Student Platform. It's run by the Louisiana Space Grant. And we have, and others that I know have, sent things to fly on HASP. They fly out of New Mexico. And then, of course, there's the Nationwide Eclipse Ballooning Project, NEBP. So that's possibly why you're watching this video, is because you're involved in this project. And so let me just close with a little bit of eclipse footage from the last time I did an eclipse flight. I guess I better click that link. One moment. There we go. So here's 30 seconds or so of some footage from a balloon flying during an eclipse. And so this was streamed footage, and hence the resolution is not that great, but the view is very interesting. The camera is a little confused about what colors things ought to be, but here I see a shadow. It's about 70 miles across. It's moving very fast across the cloud tops. This happens to be above Nebraska. That's where I was for this particular eclipse. And you'll see that the platform is not that steady, although we did manage to keep this platform from rotating really fast, which can happen, but it was definitely swinging back and forth at least some. And once in a while, the eclipse wasn't even in view. Okay, there we have it. A very quick introduction, overview of ballooning, kind of with educators, with students, with teachers in mind. And if you want to watch some of the videos, some of my personal videos at least that are linked from this particular presentation, you can follow this QR code or follow the links that are in the various slides. Thanks a lot.